This is Chapter 2, Unit 2. We're talking about grouped frequency tables. An example of a grouped frequency table is shown in the bottom left corner of this slide. As you can see, X's are a range of scores from 90 to 94, 85 to 89, 80 to 84, and so on. And then the frequency column, how many of each of the range of scores is available. So, for example, if you looked at 90 to 94, that's 5 scores, 90, 91, 92, 93, and 94. Okay, so this one uses a width of 5 in order to do this group frequency table. So let's count how many class intervals there are. So 90 to 94 is one interval, 85 to 89 is 2, 3, 4, 5, 6, 7, 8, 9. This frequency table has 9 class intervals. The guidelines for group frequency tables are as follows. You typically want about 10 class intervals. Could be a little less, a little more. The width of each interval should be easy to count, such as 2, 5, 10, or 20. In this example, it's by fives. There's 5 numbers for each interval. The lowest number in the interval should be a multiple of the width. For example, if the interval is of 10, then you should use like 0 to 9 as one of your widths, and then 10 to 19 as another interval. So, for example, the one that I posted here has a width of 5. And notice that you can count by fives for the first number of the width, which is called the lower number, and the bottom number of the interval. It should be an interval of 5. All intervals should be the same width with no gaps or overlaps in the numbers. So here's an example. An instructor has obtained a set of 25 exam scores. And to help organize these scores, we're going to place them in a frequency distribution table. And here are all the scores. First thing you want to do is kind of find the range. What's the highest number in your data set? What's the lowest number? And then you subtract those two numbers. In this set, the highest score given is a 94. The lowest score is a 52. So if you subtract them, you have a range of about 42 numbers that you need to put into a table. Well, let's explore different widths. You can use a table like this. I usually explore widths of 2, 5, or 10. And let's just see what happens. Well, if we have 42 numbers and we have a width of 2, let's divide 42 by 2. That would be 21 numbers for each interval. That's too many intervals. Well, what happens if we have a width of 5? Well, 42 divided by 5, and remember to always round up, that would be about 9 intervals. That's really close to 10. That might be the one we use. But let's go ahead and explore what happens if we have a width of 10. Well, with 42 numbers, if we have a width of 10 or 10 numbers per interval, that would only be 5 intervals, so 5 lines in the X category column. And again, we're always rounding up when we're talking about the number of intervals needed. So in this case, we're going to choose number of intervals needed as 9 because that's as close to 10 as we can get. And the width that we're going to use then would be 5. So using a width of 5, a lowest score of 52, we need to find a number that is lower than 52 that's a multiple of 5, meaning it ends in a 0 or a 5. In this case, that number would be 50. So look at the diagram at the bottom, the graph, the table, and you see the lowest interval is 50 to 54. That would be 5 numbers in each one. And normally what I do is I just start with the bottom of each interval and count. So I write down 50 and then the line above 55, 60, 65, 70, all the way up to 90. That'll cover the highest score that I need. The highest score I have is 94. And then I go back and I fill in the numbers on the right-hand side of the interval. I would fill in 54, 59, 64, 69. So that way all the numbers are covered from 50 to 94, and this definitely covers my range of scores. Next, what you would do is you would go up to your table at the top and you would start filling in. Well, there's an 82. I put a little slash mark by the 80 to 84 interval. Okay, there's a 75. I put a little slash mark by the 75 to 79 interval, and each time I'm marking numbers off my list, I'm putting little slash marks in the frequency column. Then once I have them all the slash marks done and all the numbers marked off, I can go back and count up. So from 90 to 94, there were 3 slash marks that I used. So it's a frequency of 3, and so forth and so on. But realize that by using a grouped frequency table, you can no longer determine how many of a certain score. For example, if I look at the 70 to 74 interval, I know there's 3 scores there, but I don't know what they were. I don't know if they were 70, 71, 72, 73, or 74. I have no clue what the original scores were. I just know that there were 3 scores in that interval of 5 numbers from 70 to 74. All right, let's talk about frequency distribution tables for continuous variables. Remember, when we're talking about continuous variables, we have real limits. So look at this example here. Given this frequency distribution table, what are the real limits for the interval from 20 to 21? Well, the lower real limit would be 19.5 because this interval, the lowest number in the interval is 20, and the highest number in the interval below it is 19, so halfway between 19 and 20 would be 19.5. The upper real limit for the interval, you look at the highest number in the interval, which is 21, and the lowest number in the interval above it, which is 22, halfway between 21 and 22 would be 21.5. Okay, let's talk about the range of the interval from 20 to 21. Realize that this interval actually goes from 19.5 to 21.5. So real limits actually add a half a point on the bottom and a half a point on the top of the interval, which together adds 1 point to the interval. So the way you could find the range of this interval, or how many numbers are in this interval, is you could just say the highest number, 21, minus the lowest number, 20, plus 1. That would give us 2. There are the width of 2 for this interval. That's how we'd find the range of this interval. All right, here's another example. A group frequency table has categories 0 to 9, 10 to 19, 20 to 29, and 30 to 39. What is the width of the interval from 20 to 29? And here's your 4 choices: 9 points, 9.5, 10, or 10.5. Remember, to find the width of the interval, you always have to do the highest number minus the lowest number plus 1. So you would get 10 points as the answer for this problem. Now here's the learning check. There's 3 problems here. Stop the video, do the problem, and start it again when you finished. So the answer here is a width of 10 needs to have the lowest number of the interval end in a multiple of 0, which means the number needs to end in 0. It needs to be smaller than the largest number of 86. So a number that ends in 0 that's smaller than 86 would be 80. So the interval would be from 80 to 89. That would be an interval of 10 numbers. So the answer would be A. Here's another problem. Stop the video, see if you can do the problem. Okay, so what's the highest score in this distribution? Well, we know there's 2 scores between 24 and 25, but we don't know what they are. Maybe you have 2 24s, maybe you have 2 25s, maybe you have one of each. So the answer here is you cannot determine because you don't know exact scores. All right, problem 3. Which of the following statements is false regarding group frequency distribution? Go ahead and work this one and then stop the video and start it back when you're finished. So A is true. Interval width should be about 10 intervals. Intervals are listed in descending order, starting with the highest value at the top of the X column. This is absolutely true. C, the bottom score for each individual is a multiple of the interval width. That is true. If you're counting by 5s, then your last number should end in a 5 or a 0. If you're counting by 2s, your last lower bottom number of the interval should be counting by 2s, 0, 2, 4, 6, 8. The value for n can be determined by counting the number of intervals in the X column. This one is false. Counting the intervals doesn't tell you how many scores you have at all. Only counting the frequency column can do that.